Right, so in this module, we're going to be looking at yet another way of improving the organization of our program. So we're going to build off the idea of functions and now start to break our programs into multiple files. And often throughout this course, we're dealing with sort of small targeted programming examples, and we probably won't split our programs into files all that much, in these recorded lectures or something like that. But you should start looking at your bigger programs that you're going to write as good candidates to start breaking things up into modules. It'll help you significantly in thinking about your code and organizing everything. Okay, so one of the major benefits of using functions is reusability. The idea that a function can essentially be packaged into a black box. You can call a function and you probably don't need to necessarily worry about how it does its job. You simply need to know what parameters to send it and what to expect back. So that idea of abstraction and hiding those details does promote a lot of reusability within a program, right? So we can write a function, we can write a square root function, for instance, or a cube root function, and we can call it dozens upon dozens of times within a single program and not have to repeat the algorithm. We don't have to keep rewriting the algorithm over and over again. So reusability within a program is great, but reusability across individual programs, right? So being able to use the same exact square root function in every program we write, that's even better. That's an even more powerful mode of reusability. And that's what modules is going to provide for us. So code organization. Python programs, first of all, tend to be shorter than their counterparts. And again, if this is the first language you're learning, you have nothing to compare it to. But if you do start to delve into other languages, you'll quickly find that Python has this nice ability to keep things pretty concise. But nevertheless, even Python programs can become very large. It's not uncommon to have a large program that exists over several years of people working on it. You could have easily 50,000 lines of code. Um, Keeping all of that code in one single file, just the sheer task of scrolling to the right place it gets crazy, right? So you would definitely go absolutely nuts having 50,000 lines in a single file. The other thing is that when we throw numbers like that, 50,000 lines of code out, people kind of scratch their heads and they wonder how could that possibly be? Well, the truth is that generally you've got teams of people working on these programs, so it's not like one person wrote 50,000 lines of code. Um, the issue when working in a team is that single files don't really work well either, right? So we want to be able to break things up into separate files, one to promote reusability, but two to promote collaboration. It's much easier to collaborate with individuals if each person can work on a separate file. So as our programs get larger, we start to notice that they can generally be decomposed into several um, somewhat independent parts. And well-designed programs are built of these parts are built with the idea that these parts are quite independent, and they're typically called modules, right? So when we use the term module in Python, we mean a collection of reusable and independent components, right? So the code in one file probably should not depend on code in another file. They should be modules or independent parts that can be put together. So in Python, a module and a file, an individual code file, has a one-to-one relationship. So one single file can't have multiple modules, and one module can't be spread across multiple files. There's a one-to-one relationship between them. You can think of them as one and the same. And from one file, you can import other files, other modules into your own code with the import statement. And in fact, you've seen me do this on a number of occasions when we were performing timing tests. I imported the time module. Now that time module is actually an individual file that comes along for the ride when you install the interpreter. So we're some kind of deep in the bowels of the installation of Python, there is actually a file with that module in it. And when we call import time, we're bringing that module into our program. We can create our own modules as well, and we'll generally keep them all in the same directory as our primary code file. So I'm going to go through an example of just kind of creating a reusable library. We've done the square root and we've done the cube root before. So I'm going to create a separate file called root.python or root.py. And in it, I'm going to add those square root and cube root functions. I'm not going to have directly executable code in that file. I'm just going to simply have the functions. And then I'm going to import that file into one of my programs. Okay, so I'm going to create a new file. I've got example.py, and now I'm going to save root.py. And rather than retyping this, I'm going to borrow this code from one of our previous programs. So I've got a function called square root that accepts x and an epsilon, and it's going through and using Newton's-Raphson method of calculating the square root. And we've got the cube root method that we used using exhaustive enumeration, slightly slower implementation. Okay, so one thing I want to show you is that root.py, that particular file, isn't executable. Nothing happens when I type in python3 root.py because there is no actual code that's not defined inside of a function, right? There's no global code to run, and that's to be expected because this module is not something that's supposed to be run independently. It contains utilities. It contains functions that someone else might want to call. Right? So in example.py, I can call, and let's copy the text here, I can call square root of 25 and it will work, but it won't work just yet. If I run this code, it's going to tell me, hey, square root's not defined, and it'll run once I import. So I'm going to import root, and by the way, the extension py is implied, so you don't do root.py, you just do import root. Okay. And now I can call root.square root, right? And now Python will be able to figure out what I'm talking about. And I get the actual answer. Of course, it's not exact, it's not perfect, right? Because it's a numerical approximation. All right, so just take a look at the syntax. This import root, when I import that library, that becomes available to me. And then any functions that are at the top level of this file, right? Square root, cube root, they're at the global scope of that file, are available to me through the root package. So I can call print root.cuberoot 27, and that will work as well. Any program that I write, as long as I have that root file, I can import root. And generally, I'll need that root file in the same directory as the source code that I'm trying to import it from. Okay, so that's just what I had done in this code. Python itself, or as I mentioned with time, Python itself already comes with many modules. So there's a math module with a lot of great functionality attached to it. The time module has functionality. When we start to deal with random numbers, we'll be able to import a library with that. And generally, this is the way people share code as well. So there's lots of third-party libraries, libraries that are essentially donated in an open source way by other people that you can download and you can integrate into your program through this import statement. So the idea of combining many modules is actually quite powerful. The default Python standard library, and I definitely urge you to go to this web address, and you can see the wide variety of different modules that come sort of free with your installation. There's a tremendous amount of code available at your disposal. just to kind of close out, this is a short module, but to close this out, right now you're learning how to create your own programs and you're largely writing all of your own code. In reality, as you become, more kind of doing this in a professional way, um, you'll you'll be leveraging existing modules that do work for you all the time. Modern programmers at this point really can't compete in today's environment without leveraging modules. And so being able to find, digest, and make use of documentation, like the ones at this link here, is absolutely crucial. It is probably the second most important skill a programmer has behind being able to think logically. I would put this being able to consume documentation and use modules just by reading about them is a skill that takes a long time to really learn and get good at, but it's probably the best investment of your time that you can make other than practicing programming.